Welcome to the Ruckus Associate SmartZone Administrator demonstration series for the SmartZone OS 5 release. In this series of demonstrations, we'll show you the functionality of the SmartZone OS 5, along with basic configuration of many aspects of the controller. SmartZone OS 5 is the network controller operating system that's available on the SmartZone 100 and the SmartZone 300 hardware platforms, and, as we'll be discussing here, the virtual SmartZone network controller platform. This presentation describes how zones are deployed in the SmartZone hierarchy, how to create a zone, and the configurations that are applied to zones and inherited by access points. Here are our objectives. Over the course of this demonstration, we'll discuss the role of zones on the SmartZone network controller. This includes how zones are structured within the domain hierarchy and the process of creating a zone. Once these zones are created, we'll review the zone configuration, including advanced options. So let's do a quick review of domains, and particularly domains on the high-scale SmartZone. So let's do a quick review of domains, in particular domains on the high-scale version of the virtual SmartZone network controller. So on the high scale, you have a system domain. The system domain is the top-level domain for the entire SmartZone system. And under this domain, you can create subdomains. So you can create subdomains directly underneath the system domain that are managed by the system admin of the entire SmartZone domain. And then on the high scale, you also have the option to create partner domains. So these partner domains can be semi-managed by the partner, so they are responsible for the management of domains underneath that particular domain, but still fall under the system domain hierarchy. Now, if you haven't viewed the presentation on domains and domain administration, I'd suggest you go ahead and take a look at that demonstration that's part of this series before you view this presentation so that you understand a little bit about how domain administration works and how it plays into how zones are managed under these different domains that are available on the high-scale network controller. So it's under these domains that we get to create zones. Domains, they define administrative boundaries in the SmartZone network controller. So the zones, they're going to be created by logical boundaries where you don't want access points operating together. So basically it's a group of access points that you want to have similar properties. So some of the reasons you might want to do this are for different country codes. So as you can see here, we have the UK and the USA. Now both of these countries have different rules defined in which they can operate. So by creating separate zones, you can ensure that any AP that connects through these zones has the appropriate settings for the country that they're operating in. Alternatively, you might want to deploy zones with different firmware, and this could be in order to support older access points that you have that won't support newer firmwares, or for testing features. So, whatever the reason is, you have flexibility of creating multiple zones under multiple domains that gives you a lot of freedom to plan your WLAN deployments and provide an optimal balance between performance and administration. So on the Essentials version of the SmartZone network controller, you don't have the domain hierarchy that exists. All you have is a system domain. So here you create all of your zones directly under the system domain. Now, the principles of zone breakout still applies here, just like it did on the high scale version we just looked at earlier. It's just that when we configure these particular zones, we don't have different areas of administrative responsibility. And then, of course, once we've created these zones, we configure APs to connect to these zones. And once they do, they inherit those zones' properties. So here I am logged into a virtual SmartZone network controller. This one here, as you can see, is the high scale edition. It is currently running version 5.0.0.0.675, which is the initial release of SmartZone OS 5, and this is out on the support.ruckuswireless.com website. Now, if you take a look over here, I'm logged in as a partner, so I'm logged into a partner domain on this high-scale controller. So basically, I have limited functionality because I exist within a partner domain in this network. So let's take a look at some of that. So zones are configured over here under access points. When I click on access points over here, you can see here I've got my Team X that I'm in the domain of, and this is the one I'm logged into, and I have a domain that's already configured for me, the Team X domain, which is the one shown here in the dark with the D that shows that this is a domain that I can actually create zones underneath. So as you can see here, the system domain is the one that's highlighted. So it means me as being logged in as a partner admin with only partner domain administrative capabilities, I have no ability to make any configuration changes under this domain. I have to select my domain that I'm logged in as an administrator, and then once I do that, you see I have the options up here to click on these options, and this one here, the plus sign, allows us to create a domain zone or group, and we're going to create a zone. So let's go ahead and fill this info in. We're going to call this the Team X zone. And when I click the zone button, it's going to change the screen to show information for a zone. So this is the default information that's displayed when the zone configuration option is selected. And I'll collapse all these for us so we can see some of the different options that are going to be available for us to configure in this zone configuration section. So we've got our general options, mesh options, radio options, APGRE tunnel options, syslog options, APSNMP options, and advanced options. So the general options section has a number of settings, but the most important ones we have to deal with are the ones shown with the asterisk next to them and the country code. So starting from the top, the AP firmware. This is the firmware that will deploy to the zone. The version of SmartZone you have comes with an AP firmware embedded in it, but once new firmware versions are released, you can upload those into the network controller, and they can be a list of different firmwares you might want to apply to access points. And so once that's done, you can select which firmware you're going to use for a particular zone by hitting this arrow and selecting which of the firmware you'd like to apply to the zone. Next is the country code, and the country code sets channels and port settings. So these are critical because every country has different regulations on how radio channels can be used. So you always want to make sure that you have the appropriate country code selected for where this zone is going to operate. You have some other options where you can put in locations. These are just informational areas for you to provide a location, additional location information, GPS coordinates, which are useful when you're using the map feature because it'll actually lay the zone down and where it operates at, and you can place those on the map for you. And then the most critical one is the AP admin logon. So this is the logon to the AP itself. So once the AP joins the zone, it's going to inherit the logon requirements that are given by this zone that you create. So here you can create, whatever admin credentials you want. We can just call this, the login would be AP admin and any passwords you want. Then you have the option for the time zone where you can leave that as system defined, where it'll inherit the time zone from the controller. Or if it's perhaps operating in a different country or a different state than the controller, you might have this zone be user defined, and then you can use the drop down box and select the time zone for it. Now the historical connection failures option here, just turned on by toggling the switch, will allow the AP to send information about failed connections back to the controller to have historical and troubleshooting data available to administrators. Now next we also have data plane zone affinity profiles. If we're running a separate SmartZone virtual data plane, we can have affinity, basically saying that all APs in the zone will always go to the same data plane, which is beyond the scope of this course, but if you did have multiple virtual SmartZone data plane virtual machines deployed, you could configure that here. And then we have SSH tunnel encryption, where we basically just define which type of encryption we want to use when establishing the SSH tunnels. That would be AES 128, which is the default, or AES 256. Next, let's take a look at mesh options. Over here, we have the option to turn on mesh networking in this zone. Now, mesh networking is a mechanism that allows APs that don't have direct connectivity right back to the controller to mesh with another AP that does have connectivity to the controller. So we can turn that on right here, allowing mesh networking. Now, once mesh is enabled, a hidden SSID will be created for mesh communications. So this mesh name and the mesh passphrase should be noted for possible troubleshooting and for potential access point recovery. Starting with SmartZone OS 5, you'll notice here as well that mesh networking is now available on both 2.4 and 5 gigahertz radio, so that's new in this release. And then just note when mesh is enabled, access points will attempt to find other mesh-enabled access points and then calculate those mesh links, which causes some additional overhead, especially if the access points are unable to find any mesh partners. So mesh shouldn't really be enabled if it's not absolutely required in the zone. So in a typical mesh deployment, an AP has to first be staged with a wired connection in order to enable mesh networking. Then it gets deployed to its unwired mounting location to start operating correctly. Now in SmartZone OS 5, this new feature called Zero Touch Mesh was enabled, and this feature allows a factory defaulted AP to discover a mesh network over the air on the 5 GHz radio. So this takes away the requirement of connecting to a wired network first. And Zero Touch Mesh is just enabled by toggling the switch here. So we'll go ahead and disable it for now and continue on to the next configurable option here, which is radio options. Now the radio options you'll see here are dependent on the country code setting. So up at the top when we selected the country code, this determines the radio options you'll see in this particular menu option. So here we're seeing options for this zone that's set to United States. So if you're configuring for a different country, you might see some different things there. Now these refer to two specific settings. The first setting is the channel range, and by default all permitted channels on the 2.4 GHz and a subset of the 5 GHz channels are available for the access points. However, we increase the number of 5 GHz channels by turning on DFS. And we do that here by toggling this switch. And notice the change here. Now DFS is dynamic frequency selection, so we're allowing all of the channels available in the 5 GHz range to be available by toggling this switch. Now in both these scenarios with DFS on or off, all of the check channels, they're available for access points to provide services for WLAN services and to perform background scanning. Then we have the other radio options. These are broken out by the 2.4 GHz band or the 5 GHz band. So if you look here, we have channelization. So under channelization to the 2.4, we can select auto, 20, or 40 for the channel width. Now auto, the access point will automatically select the channel width based on some other factors. On the 5 GHz, we have the options of 20, 40, 80, or 80 plus 80. Next, channel defaults to auto, so you can leave it at auto or you can select a specific channel. But keep in mind, this channel applies to all access points that reside within this zone. So it may not be the best idea, but it could be for your environment. And then of course, for the 5 GHz, you have the channel selection for both indoor and outdoor. And these channels are based on what you have available to you in the channel range shown up above here. Next, we have auto cell sizing. And again, this is for either the 2.4 or the 5 GHz or both. Now, auto cell sizing is a feature that allows Ruckus APs to share interference information with each other and then automatically adjust transmit power and receive power parameters or the cell size to mitigate interference. So when it's enabled, the transmit adjustment settings are disabled. As you see here, when I turn this on, the setting grayed out and is not available for me to make any adjustments. Now, speaking of transmit power adjustment, it's another drop down here where we can pick between full and minimum and a nice long range in between. And these settings allow us to choose the maximum transmit power used by the access point. So from the default setting. Now, full auto is the highest transmission power allowed according to the regulation domain and the access model. So basically where this is operating based on the country code we selected and the access point model. And then the dB scale we're showing here represents how much power the transmission power is decreased relative to full. And then the minimum setting is the lowest possible transmission value that the access point can make. Now this again depends on the model and the chipset, but it's commonly set to 0 dBm or 1 milliwatt. Now it's important to consider that if you make any changes to this, you're going to want to be prepared to test and analyze the results and see how those changes affect how the WLANs operate in your environment. So, it's really most of the time just recommended to leave all these settings as the defaults and let the system work itself out through some of these automated features that are available to it and really only change things if you very specifically need it. Okay, next we'll look at the AP GRE tunnel options. And before we talk too much about this, let's talk a little bit about how zone tunnel operations work in SmartZone OS 5. So here I'm just going to show you a quick overview of the zone tunnel options in the Ruckus SmartZone Network Controller running SmartZone OS 5. So in this release, we allow 4 different types of tunnels from a given AP in a zone. So we configure those in the zone. And what tunnels do for us is allows us to tunnel traffic from clients on particular WLANs back to some other network as opposed to being routed directly from the AP out to wherever they're going on the internet, you might want to have that traffic tunneled back to a specific network. For example, let's say this is a public venue, say a shopping mall, and you're providing wireless access to multiple stores. Well, each of those stores don't want their data mingling with other stores' data, so they might have their own dedicated WLAN, and those WLANs are going to have to go back to their corporate offices. So with the SmartZone network controller, we have the option of creating 4 tunnels per access point. One of those can be a Ruckus GRE tunnel that'll terminate back to a Ruckus virtual SmartZone data plane. And then we have 3 soft GRE tunnels available to us that we can branch off 3 other WLANs or more than 3 WLANs to those different company networks. So again, we're showing an example here of a single WLAN going to a single company, but multiple WLANs can all tunnel back to one of these soft GRE tunnels or this Ruckus GRE tunnel. So there's some flexibility there. Okay, so let's go back and take a look how the AP GRE tunnel options are configured over here for the WLAN. Just keep in mind here when we're configuring it here, we're configuring the tunnel profiles that are available to WLANs that are configured on this AP. So this is the zone configuration. We're not dictating what profile will be used. We're just giving the ones that will be available to WLANs on the APs that join this zone. So everything filters down essentially from the zone configuration down to the APs and then down to the WLANs that are created on those APs. So for the Ruckus GRE profile, there is a default tunnel profile for Ruckus GREs. You can select that one, or if you wanted to create your own tunneling profile for Ruckus GRE, you can click the plus box here. It'll open up a dialog, let you give it a name, and change some of the variables for that GRE profile to fit whatever your needs might be for this Ruckus GRE tunnel profile. We'll cancel this here. And for the soft GRE profiles, we can go in here, and if we have none available or none configured yet, we use the select option to pick which ones we want. Now, if there are none available here, we can just create them by clicking the create button. So let's just create one real quick here. We'll just call this third-party profile. We'll give it the IP address. And we'll leave the rest at default values because we're not really worried about it. So we've given it a name, we've given it an IP address, so we're okay. So we select the profile we want from available profiles, and we move it over here to these selected profiles. And if we want some AAA affinity, which we can configure, which means we associate it to a AAA server that's been configured, we turn that on here. But we'll leave that off for now. And now we have a profile here. So as I have one profile, I'll also have the option to turn on an IPsec tunneling profile for this third-party profile. So then I can secure this soft GRE tunnel back to wherever it's going to that IP address we provided and allow this to have a secure tunnel. Now, keep in mind, if I configure multiple soft GRE profiles, so if I configure this select button, I create another soft GRE profile, this option for IPsec tunnel profile will not be available to me. It's only available if I only have one soft GRE profile selected for this WLAN. So just keep that in mind when you're configuring this feature. Okay, next we have the syslog options. So under here we can enable an external syslog server for our APs in this zone. So basically this is for the APs themselves to send messages to a syslog server logging events. So all we need to provide here is we need to provide a primary server address. The default port is 514. We have the option to select protocols of TCP or UDP, and we can also configure a secondary server to be sending these syslog messages. And then we have our event facilities and priorities, but the ones I want to point out to you down here is the send logs. So we can send general logs, which is just information about the AP, any events or logging related to the AP's operation specifically, or we can send client flow. So we can send information to syslog about client flow data. So these are related to client traffic usage through the AP. Now this requires, turning this on requires additional configuration at the WLAN level. So there's a little more to this than just toggling this checkbox here. You have to actually enable it on the WLANs that are configured on this AP that's a member of this zone. And then the other option here is all logs, which will basically send both the general logs and the client flow logs. But again, when all logs is selected, you'll still have to do some additional configuration at the WLAN level to allow this client flow information to be sent. So as with syslog, we also have the option, I'll disable this, is to enable SNMP for the access point. So this is, again, the AP sending information to an SNMP server. So when this is enabled, we have the option to configure an SNMP version 2 agent and the community and the target for where we're going to send traps or who can query the AP, or we can configure an SNMP version 3 agent which provides a little more secure access to the access point for collecting information. And then of course you can configure a target for traps to be sent from the AP to an SNMP server for event notification information. So the final section of the zone configuration is the advanced options. However, due to the volume of advanced options available and time constraints, this section will be covered in a separate video. So please check back in the videos in the series for the zone configuration advanced options video for a demonstration of the configurable parameters in the advanced options section of zone configuration. This concludes this presentation covering many of the configurable options available for zone configuration. This presentation is part of the Ruckus Associates SmartZone Administrator Demonstration Series for SmartZone OS 5. There are many other demonstrations detailing configuration processes and options, so I hope to see you back for more presentations in the future. Thank you.